As this is part 2 of the plotting tutorial, we're just going to jump straight into it. And in this session, we're going to be looking at plotting different types of graph from that scatter graph that we looked at last time. And then we will look at how you can save and export graphs to use them in your reports or your dashboards, or however you want to use them. So the first one of these we're going to take a look at is the bar plot. And bar plots are generally used to compare values between groups of data. So let's, for example, group all of the cars into the number of gears that they have, and then compare the average quarter mile time for each of those groups using a bar plot. So we have a little bit of data manipulation to do before we can do this bit. And the first thing is to get the average quarter mile time for each of those groups. So let's define a new object called qsec_g to stand for quarter mile time group. And to do this, we need to use an aggregate function. And what an aggregate function does is it groups the data you're looking at and performs a function that you specify on it. So we could group the data by the number of gears the cars have and perform an averaging function on those groups. So we need to define an x argument, which is the piece of data we're interested in, so the quarter mile time of the cars. So let's look at the C data frame and the quarter second time. And then we need to define a by argument, which is what we want to group the data by. So we want to group it by the number of gears the car has, and this has to be supplied as a list. So first we'll get the number of gears of each of these data points from the data frame. And then we just need to convert this, what is currently a vector, to a list. And all you have to do for that is just put it in a list function. And finally, we need to define what function we want to perform on these groups. So that is done using the fun argument. And we want to take a mean of these groups. So the mean average. You'll see that up here we have a new object and it has 3 observations of 2 variables. So the columns aren't particularly nicely named. You can see that we have a group for each of the number of gears the cars have and the average quarter mile time for those groups. And now we can use that data to make our bar plot. Now, as I said, the column names aren't particularly nice. So we can use something from the last tutorial where we redefine the column names here. And that is the column names function. So if we simply use col names on our object here and reassign a vector of the names that we want to assign to those columns. So let's just have a vector. And the first one is gear. And the second one is average qsec. And if we run that and now look at our data frame again, you'll see that we have nicely named columns. So now that we have nicely named functions, we can actually plot our graph. So for that, we need a bar plot function. And we're going to define the height of each of the bars using a vector. So obviously we want the height to be the average quarter mile time for each of the groups. So we simply need the qsec data frame. And from that, we want the average qsec. And we can run that and you'll see we get a bar plot over here, but it doesn't really mean a lot at the moment. So let's add a couple of things to it. We'll add a names argument, which is names.arg, and that needs a vector. So that's just going to name each of the bars. So we just want it to be the number of gears. So we'll just have it as 3, 4, and 5. And if we run that, you'll see that we get that nicely now. And we can make this look a lot nicer. And I've just got this already defined here. We're just changing some of the arguments that are the same as we did in our basic scatter plot. So feel free to take a closer look at them. But essentially, if we run that, you'll see that we get a nicely labeled, titled bar plot with some different colors, showing the average quarter mile time, dependent on the number of gears each of the cars has. So on to histograms. A histogram is an approximate representation of the distribution of numerical data. So we want to group our numerical data and then try and show its distribution. And this is very easy using the base R package. There is a function called hist. And let's take a look at the distribution of the horsepower of the cars. So we want our C data frame and then horsepower. And I need to make sure I get an underscore in there. And you see it's as simple as that. So we now have a histogram of the horsepower of the cars and the number of cars which fall into each of these groups. You can change the number of groups that the histogram has using a breaks argument. So breaks equals 3. And you'll see that that now has 3 breaks, so 4 groups. Again, I'm not going to show you everything you can change about a histogram, but I have changed a couple of things just to make it a bit nicer. And you'll see that we now have a nice histogram of the distribution of horsepower for our sampled cars. So another common way to show distributions is using a box plot. So let's just show the same distribution, but using a box plot instead. We just need a box plot function. And again, we'll just give it the C data frame horsepower values. And that's as simple as that to get a box plot. And again, there's many other things we can do with this. And I'm not going to go through them all on this tutorial, but we can plot multiple box plots just by supplying several different data arguments to the function. And all I've done is split up the horsepower data into the number of gears that each car has. And so you'll see that now we have 3 different box plots all shown on the same graph, dependent on the number of gears each car has. So one final graph that we might want to look at is a density plot. This is another way of showing a distribution. So we can use the density function to estimate a density function for our data. So let's just supply this the C data frame horsepower values. And you'll see that that creates a density function for us down here. And now all we need to do is plot that density function using a plot function. And you'll see that our density function is plotted on the graph over here like so. And something common to do is to overlay that onto a histogram. So let's just get our histogram from earlier. And if we run the histogram from earlier, there we go. And then we just use a lines function. So remember the AB line function we use to overlay a line onto our graph. Well, this is very similar. We're just going to use this lines function to overlay the density function onto our graph. And if you run that, that's exactly what happens. Now, one thing I forgot to mention just there, when I plotted the histogram up here, I defined an argument called probability equal to true. And all that does is change it from a frequency diagram to a probability density diagram, because that is obviously how the density function is plotted. So if you were to plot this density function on the original histogram, then it wouldn't really make sense. And again, I've just played around with some of the different arguments here to make this look a lot nicer. So we've learned how to make lots of different nice graphs. And as I said, there's many more things you can do with this. So it's just about having a play around with it. But now that you've made your graph, you're going to want to use it in a report or something like that. So let's just quickly look at how to save and export graphs. Now you can do this using the RStudio graphical user interface. Simply come over here to export and you can, click save as image, and that's fairly self-explanatory. But you may also want to do it using your script. So to do so, you can use something like a JPEG function. And all this does is it opens a new JPEG file with this name and a width and height specified here. You then run your plot function whilst that file is open and use a dev off function to close the file afterwards. So I've just got one of our graphs from earlier, and I'm going to open a file, plot the graph, and then close the file using this. And if you run all of that and then navigate to the place where your R file is saved, then you will see that this file is now saved there too. And if we open that up, you'll see that it is our scatter graph from earlier, saved as an image. So there it is, base R plotting. We've learned how to make lots of different graphs. So that's quite a long one, guys, so well done for sticking with it. I encourage you to have a play around with the different things that you can do with these graphs. And next time, we're going to be looking at a third-party package which was created to make plotting graphs in R even better, even more customizable, easier to do, more intuitive. And that is called ggplot2. So be sure to stay tuned for that one. Thanks for watching and see you next time.